Hi, so my name is Tony Jones. I work in the SUSE Labs kernel performance team. And Giovanni had asked me to give the dictionary definition of BOF. No, actually, I won't do that, but birds of a feather flock together. So anyway, so the purpose of this talk is to discuss some of the things that I've tried to do to change how we build user space programs from kernel source. But mostly what I'm interested in doing is getting advice from people because I've kind of reached a dead end. So there's probably some people here who don't know this. There are actually user space programs in the kernel source tree. And they are located in the top level tools directory within the kernel source tree. And way back in 2631, perf was the first package to be added into tools. By 3.0, we had this many, 4.0, this many, 6.0, this many. And I cannot tell you how many of these we package for sleep, as I have no idea. And that's kind of somewhat of an interesting thing. So, brief history of how tools perf came to be. So there was what's called the dueling performance monitors. There's a LWN reference there. So perfmon originated on Itanium, and it was kernel code with a completely out of tree. pfmon was the user code, libpfm was the library. Posted for review on LKML, led to the perf events counter proposal. And the thing that's important is before all of this, OProfile was the main profiler that was available, and it was a completely out-of-tree user space, and that was kind of regarded as a bad idea, and they wanted to bring that code into the kernel tree. So that's how the tools tree came to be, to kind of bring the user space component matching the kernel component into the tree. So since then, there's been kind of a slight reversal. So trace event, which is to pass the ftrace events, and here's the original commit message. In 2020, that actually got forked into its own Git repository to be used for making packaging easier to use. And libtraceevent.git now gets released as a version tarball as well, and that's what we package in SLE. And by November 2022, it had actually been removed out of the kernel tree tools. And for BPF and BPF tool, something similar is going on because they exist in the kernel tree, but they're also now being mirrored into GitHub. And Xiongxi is going to be packaging these for SP5, and I think it's an open question as to whether he's going to use the GitHub version or the kernel source version. So one of the things is it's kind of hard to know how many packages we actually build out of these dependencies for SLE. There's no real way to know. But the ones that we do, building them to an RPM can be kind of challenging. So how do we build perf at present? So the thing to remember is it's built as a distinct build service package. So there is a perf package, it has a spec file, has changes, and most importantly, we collect the patches for perf in the perf package, not in the kernel source, Git. And that has some advantages. We get a clear change log every time we make a change to perf. We can release independently of the kernel cycle. And there's an implicit indication each time we check a change in that this is going to be a maintenance release, and it's in a format that is acceptable to the maintenance department, and there's an actual change that needs to go out. But there are some disadvantages. So it's hard for others, especially in the kernel team, to check in changes. Somebody's on vacation or somebody just makes a mistake. We could probably prevent this using a hook, but there's nothing that actually prevents somebody from checking in changes for perf into the kernel Git. And back when we were taking stable, this happened quite often. We'd take a stable patch and it would actually be to tools perf. It would go into kernel Git. There's no way to know, no way to trigger an update of the user space package. There'd be no change log. So it would never get released until the next time we actually pushed a perf update out, and then it would mysteriously come out without a change log, and it would be part of the new perf package. And the other thing is that quite often somebody will check a change into kernel Git, and it ends up actually breaking because it clashes with a patch that's local in the perf package. So that's a major disadvantage. The other disadvantage So git fixes, they all apply to tools perf, just as they do to the perf events kernel part. But any packages we don't take, we still need to blacklist them in the kernel git. So we can't get away from the kernel git. And the other thing I'm going to talk about later, if we want to do greedy backporting, we can't use any of the cool tools that we've developed for the kernel tree. So you're basically taking perf patches, you're putting them into a spec file, you're building them with a normal RPM build. If it breaks, you have to kind of figure out in that chroot how it broke, and it's nowhere near as convenient as the sorted series and what Rapid Quilt can provide. And the more greedy we get in backporting, the more clumsy this process becomes. So to quote the inimitable Veruca Salt, so this is what I would like. So what I want to get to is that we maintain the user space patches for everything inside tools, inside kernel git. That would allow us to use the forklifting or greedy backporting to take large numbers of patches and leverage the tools. One of the reasons I didn't do this before was before we had Rapid Quilt, having like several thousand user space patches in the kernel tree, which all the kernel developers had to sequence when they had no interest, was kind of a problem. But now with Rapid Quilt, that's kind of a non-issue. So what I want is for it to get integrated into the scripts.tar.sh process. So one thing to remember for people who are not familiar with our kernel tree, we don't have a regular kernel tree like the upstream kernel. We have a git tree that is a set of patches maintaining git, and those get applied over a kernel tarball. And scripts.tar.sh is a tool that basically creates a kernel source directory for submission, and there's two primary use cases here. There's the developers who will run this to create this kernel source directory because they want to use OSC wrapper to either build it or upload it for build. And then there's the branch maintainers who run the same workflow, but they then push the changes into the build service. And what I'd really like is no special handling. So anybody can just check in tools patches as normal, and they will eventually make their way into a SLE maintenance update. And the difficult one, only changed user space packages would get released. So one of the difficulties here, this kind of exists at the kind of intersection of the kernel git process, the build surface process, and also the maintenance process for SLE. In the past, I know we've had complaints from the build service team that we've messed up our changelogs and our changelogs haven't been good enough, so I'm kind of working on the basis that changelog quality is important. But there's definitely been a degree of procrastination here. I mean, my interest in this kind of, the further we get away from SP0 and the more patches I have to handle, my interest level kind of increases. And then when we rebase back down to SP0, my interest level in getting it fixed kind of goes away, and then it ramps up again, and then it goes away, and so. Yes. Well, except that but now I believe we only go 2 service packs without a rebase, I believe. So it's not so bad anymore. So my focus on this is mostly on SLE. Factory is less of an issue because we rebase the kernel far more often. So looking at CentOS, which is RHEL, they build perf as a sub-package of kernel-source.spec. And if I downloaded that packet, I set up a CentOS VM and installed perf and run the changelog, and this is the changelog. So unsurprisingly, it's the entire kernel changelog. So eventually, at some point in time, there might be a perf entry in there. So that's kind of what I was hoping to not get to. So the issue really is making perf a sub-package in kernel source is not a particularly big deal, but generating a changelog is where I've run into the difficulties. So my first attempt, so I mentioned we have this thing called scripts.tar.sh, and that basically takes our git tree, which is a tree of patches, runs the git revlog on that, and produces this file called kernel-source.changes, which is our changelog. And so my goal was to post-process that into a kernel-source perf.changes. And that required 2 changes. I had to expand the commit IDs from 7 characters because they actually clash. And we tend to collapse in the changelog. We collapse multiple commits from the same person into one entry. So I had to temporarily undo that. So it takes about 4 seconds for scripts.tar to generate the kernel-source.changes, but it takes over an hour to inspect that to determine which of those patches touches tools.perf. And the problem is actually looking at the git diff and inspecting the change to see if it's a perf patch is really expensive. One of the things that makes this worse, so in that 4 seconds, we actually, the rev log is actually 102,634 commits, and every single time you run scripts.tar, we regenerate that kernel-source.changes all the way back to the backstop in kernel-source changes.old. And it's not entirely clear to me why we do that. I've told there's a reason for it, but the sheer number of commits, we're doing it over and over and over again, it's fairly efficient to process the rev log and look at the commit messages. You can, as I say, you can do it in 4 seconds, but to actually open all those commits and over and over and over and over again is really redundant and takes forever. So, but we end up with a nice change log like this, and it's quite old because most of the patches get collected in, as I said, collected in the perf package, not in kernel source, but you end up with a change log that looks like this. So that was really slow. So I decided that I was going to try and make it a little faster. And so scripts.tar invokes this script called git-log-to-changes, which is written in Perl. And I rewrote that in Python to use pygit2 using a topological walk. And it ends up being slightly faster than the 4 seconds to regenerate the kernel-source.changes, but same problem as the prototype. As soon as you actually have to inspect the commit, the performance just goes down the toilet. It's about 4 seconds per 100 commits, and I said there's 162,000 in the rev log. So I posted long ago on the curling mailing list about this, and I said this is the problem. And the main solution I got was, well, why don't you use the expanded tree? And for people who don't know, the expanded tree, as I said, we have a base tarball, and then we have a Git repository full of patches, and script series to Git is used to basically take create a Git repository from these. And we can also check it out directly. But the issue is that it's notional only. So, I mean, it's not part of the actual development process. It's purely, if you want to use it, you can use it. But the actual branch maintainer still runs script-tarp.sh to push the changes into the build service. There's no expanded tree. So using it is just kind of complete tangential to the problem. So the other thing that's kind of come up from time to time is, well, why don't you go ahead, put the patches into kernel git, but do the work somewhere else. Like do it in the kernel CVS backend somehow. Still package up as a separate build service project in perf, but BuildRequire kernel sources before, but somehow this changelog will somehow mysteriously arrive from this out-of-band process. But I mean, there's a major synchronization problem here because it's unclear when the kernel source actually becomes the new kernel source. I mean, it goes through, it gets released, it comes out of maintenance, and eventually it'll appear in kernel source. So you check your patches into kernel git, but when you actually have to loop back and package it into the user space package is really unclear. So I'm kind of iffy on that. So bottom line, to me, to do it this way, the performance needs to improve. So we need to inspect less commits, which means we need some state. And the only state we have right now is that RPM kernel-source.changes.old backstop. And whenever I've brought this up before, there's been a legitimate lack of interest in creating any more state in the kernel tree. So the way to do that is either via global change impacting that backstop or a more limiting backstop just for the perf user space changes. One obvious way to do it, tag the commits on the way in. So scripts.log, it looks at the commits at that point in time. If they touch the user space, tag the commit message. We've already seen that we can process the commit message really quickly. And so only look inside the commits that we've tagged. That would make a significant improvement. So I was talking to Mikkel about this a week ago, and he said, well, look at this. And so I thought I'd tried this. So there's a kind of an optimization based upon our Git layout. So I'm not picking on, this happens to be a commit. So if we look at this commit here, so the things that of interest are, there's the tree object, and there's the parent object here. And so basically, if you run git cat file on the tree object, this is what you get here. And the interesting item we're interested in is patches.suse, which is where we collect the actual individual patches for a commit. And that's a tree object also. So if I do something, so this command here, the first commit ID is basically the patches.suse tree object, and the second one is the equivalent for the parent. So if I run a simple diff on that, I get the patch that we've added. So in theory, it's possible to use this as kind of a slightly more optimized way to go through and figure out, since I know this is how the Git repo is laid out. So I already had this Python code that I wrote, and so basically this code here just takes the tree, takes the parent, and then it iterates over the tree to find the patches.suse directory. And that's pretty low cost up to this point here. It's about 3/1000ths of a second for every 100 commits that we do. But as soon as I try to iterate over the entries in patches.suse, the performance drops to 6 seconds for every 100 commits. Instead of doing, so there's obviously a problem in the Pygit implementation. If instead of doing this iteration, I just popen out and run that diff command, it's about 2 seconds for every 100 commits. But, yeah. Can you use the mic? Yeah.
Have you tried using the key lookup for the tree object? So instead of iterating all the entries, you just look up a certain path in the parent tree.
For what? But for the first, you mean for patches.suse?
Yeah.
Well, this is really fast. I mean, as I said, to get to this point in the comment, it's super fast. The problem is generating the list of commits that are in the parent directory so that you can diff the two of them to figure out what's the commit.
I see. I missed out on this.
No, that's okay. That's okay. Good question. Yeah. So I don't know. So the summary is that Git optimizations may help, but the performance is still an issue. So to me, reducing the scope of what needs to be processed is really the best approach. And like I said, this is a copy from the previous slide. And there are some other issues. So one issue is just considering perf. What would be considered a perf change? Because it's not simply what touches a patch that touches tools perf. It's actually perf makes use of patches that touch parts of tools lib, tools BPF. So that's one more level of complexity. The other question is this anything of interest to anybody other than me? And I mentioned, Sheng Si, he's not sure if he wants to use GitHub versus the kernel source. I talked briefly, Thomas Reniger maintains, as I said, it's hard to tell, but it's hard to tell which packages BuildRequire kernel source. The one nice thing about how Fedora handles this is they package everything into one kernel tools package, and right there, these are all the and everything is built as a sub-project from that. So we don't really know this, but I know he maintains TurboStat, CPU power, and a few others. But these are really low number of changes, low number of Jira requests, low number of Git fixes. And I mentioned this to him, and he didn't have a tremendous amount of interest. Oh, yeah.
Just really only wanted to quick mention that, yes, it's interesting, for example, to me as well, if in the context of maintaining KVM stat, which is still there. Okay. And for now, I use the approach that you said you are using. So it's it's its own OBS project, which imports the kernel sources and the patches, which are mostly backport. So I have only a few patches. That's why it's not a big burden. Are in the OBS project for KVM stat itself.
Right, so you have the same problem, which is somebody can check in. I mean, we could put a hook which prevents anybody from checking in a patch into the kernel Git, and we still have the same problem that we can get these clashes and stuff breaks from time to time.
And also there is a Linux GBC devel, so that's a Linux header files for the user.
Yes, yes.
That should be also generated directly from kernel source.
Yes. Good point. And the other issue is, the one nice thing about how you package this and how packages perf is that we get control when it goes out. I don't know if you happen to look at that RHEL CentOS release, but that changelog was the kernel changelog, which implies that that package is being issued every time, whether there's a perf change in there or not. And I believe that it'll be the same if we package any packages. Go ahead, Robert. Oh, so I believe that that's going to be the case, which is that it's not the end of the world, but it's not ideal. I mean, it would be the ideal is that, especially if we had some of these packages that don't change very much, if we were to generalize this and ship 20 or 30 different user space packages out of this, do we want to issue 20 or 30 user space packages into maintenance every time we issue a kernel update when none of them have changed? It seems kind of a hassle. Maybe it's not the end of the world for perf. And there was one thing, in factory this would probably be solvable via the reproducible builds concept, but that doesn't exist in SLE. So, and Robert, go.
So have you considered using the source service? So we have a similar problem for our image descriptions, cake recipes. And what we do is basically we store the state in the package and then let the source service check out the Git repo, take the state from the file that we have in the package, which is the previous commit, and then diff just between the previous commit when it was generated to the latest commit, and then you have a much smaller set to process to do the changelog.
No, I wasn't even familiar with that.
Yeah, so you can have a script in IBS, basically let it check out the kernel Git, and then you take the state from the package, which is the commit number.
So how do you know when to do that, though?
Well, you just run the source service whenever you want, and then it takes the Git tree.
Well, sure, but I want it to happen when I check in a kernel's.
Yeah, you check in the kernel, and once it's in Git, then you go to the package and you run source service all, and then you get the diff. It's quite simple, actually. And then you just have the difference between the last time you generated the changelog and now, and that's a much smaller set you do process. I'm sure your timing issue goes away.
Anybody have any comments? I've never used this, so.
Yes, there is the thing that for Linux glibc devel, it's not acceptable for it to be released with each kernel release, because everything depends on Linux glibc devel. And that means that with every kernel release, you would rebuild the board. That's not acceptable.
Yes. Also, the going discussion right now for the ALP is that we use multi-build stuff instead of the linked packages. So that was a request from the ALP. And if we do that, that is a problem because it means that it's really always rebuilt. For example, the perf package, we cannot do control, so at which timing it should be built. So in that case, it cannot be the linked package or some multi-build is not easy. So somehow perf would depend on the kernel source or whatever. So different mechanism is needed.
Did you thought about to just use for the changelog all the commits that are on top of the base kernel version in kernel-source? Because that's what I was looking into for Linux glibc devel.
Well, that is, I mean, this is our set of patches. I mean, it's hard to explain. I mean, the revlog is our Git tree that's over the base kernel source version.
Yeah, but you can, if you can identify the commit where we changed the base kernel version and just go from there, then you should just get everything on top of that.
Well, sure, but that is several thousand, several tens of thousands of patches, probably.
Yes, but not.
Well, no, sure. No, sure.
So how do you identify the commits, do you grab them for some of the?
There's a matcher in libgit that you can match against a commit and find out if it matches against a particular path.
So
otherwise, you can
could you like first match everything under patches SUSE and then give the list of the patch files to git log -- and the list of patch files that
possibly. I mean,
faster maybe.
Maybe, yes. So there's possibly a way to do it which doesn't involve using the kernel. I mean, my goal in doing this was to do it as a side effect of generating the kernel source changes file, but that's clearly not going to work.
You only need to scan the changelog only from the last entry, which is already in the perf changelog, right?
Well, except we don't keep that changelog in the tree, I don't believe.
Yes, but you can grab it from the build service or somewhere. Sorry?
There is no ordering of the commits. You can merge all commits. So there is no ordering.
Yeah, this rebasing and merging of all commits and why we walk back is a part of the problem, but I'm not sure of the reason why.
There is no ordering of the commits.
When we listen back to this, we remember it was an insightful observation.
So for BPF, I'm actually still I still will have to do the kernel source. Well, the same thing as you for the 15 SP3 to SP5, because I'm not moving to GitHub. I cannot really move to GitHub for those. And for the ALP and possibly SP6, maybe. So like I might end up getting the best of both worlds or the worst of both worlds, depending on it. And so another thing is possibly a stupid question, but if we put all the patch for the user space in a different directory, like patches that tool, I guess, like would that help?
Yeah, it would. I mean, given the performance issues in iterating over that large of a patches, that could help. Yeah, if we had patches.userspace. But still, the fastest way to do it is I think is just to tag the patch on the way in. I mean, at that point in time, I mean, I mentioned this to Mikhail, and he was concerned that we'd somehow miss patches in doing this, but I'm not really sure how that would be. I mean, if we just, when we run scripts log, if we identify that this touches a user space, we put a tag in there saying this is a user space, and we added it in after the commit log that the user specifies, and then we can find them really fast. That just seems like the easiest way to do it to me. And then after that, there's a variety of optimizations we can do if that's not fast enough, such as, I mean, given how fast we can scan the entire 163,000, and given how few user space patches there are, I think that alone will probably solve the problem. After that, we could do various options of limiting the scope of the patches. But that's kind of the change that I would like to make, is to put that to and I think that putting it in scripts log is good enough. I mean, that would catch. I don't believe there's necessarily any ways around that, but maybe there are. But
are there any dependencies on other header files or something like that, which are not in tools directly?
Yeah, there's dependencies on tools include, which gets itself mirrored through patches from the regular include file for various reasons. So, yeah.
What you could do, there is.
Can you use the mic? I was asked to make sure everybody uses the mic. Sorry.
Can you, if there is few patches for perf, can you put the list of patches that touch perf in a file? Like we have a list of patches that should be excluded from the changelog, and we have a list of patches that should be excluded from git fixes and stuff like that. So you could put a file into the kernel source that says, this is the list of commits that include perf changes.
Sure. Yeah, I mean, it's slightly awkward, especially if we generalize it to other things other than perf, and it's one more thing that somebody. I mean, I guess we could have the hook or the scripts log update that automatically somehow if the patch touches. But yeah, it's entirely possible that we can. I mean, there's lots of ways we can do this by adding more information to the tree. But when I brought this up before, it was like, no, we don't want any more state. You know, so everything's possible if we. So what Meko's suggesting is we basically have a file that basically represents patches.tools, I guess, but
I just thought that it's not, right now that whether it makes sense to put the patches in different directory, so not patch SUSE instead of patches SUSE, patches tools or whatever, then differentiate.
I mean, I still think that if we just tag the patches on the way in, that we will solve I think we'll find we solve nearly all of the performance problem, because we're just not going to have. It's going to be very fast to find them, and they're relatively small as a percentage of the total number of patches.
Yeah, but sorry.
Unless somebody sees a problem with that.
But my primary question is that changelog so important? I mean, there has been always complaints from people that kernel-source, the kernel changelog is way too huge. And for in the future, we want to strip down make it small. And I wonder whether we want to keep that.
Right, that's one of the reasons why I mentioned this. Is do we want to revisit that backstopping procedure here and change that, because obviously that would have a side effect on this as well.
Yeah, but it's not necessary to put every single commit change in the changelog too. We can just put the commit log, and the details change can be referred in somewhere else, or we put some text, so change commit log text in kernel-source package itself also. Yeah, sure. Yeah.
I mean, all that I care about is in the end, when this gets to the maintenance team, if there's not a decent changelog, they're likely to object. I mean, they have in the past, and I think if I gave them that changelog, they would probably have a minor flip out. So, yeah.
The big changelog is also an improvement for support and from support. So if customer asks, point me to the change, that is important for us to show it to customer. Here is the change that fixed this issue. You have to update the kernel.
I understand. Yeah.
Man was queuing for commenting.
Just going back slightly, I think you're suggesting on tying this into the series log and enforcing it by GitHub would be like tagging the patches individually. So if the patch being added touches tools at all, we already have like mandatory metadata like patch mainline, references, the correct signed off, they're all enforced. And just say in the event that you're committing a patch that touches tools, that there is a new meta tag that says kernel tools, and you name what it is. So like it would be perf or turbostat or CPU power. There would be a need to go at one point to update all existing patches that affect perf and annotate them once. But you would need to enforce that at the GitHub level, because not everyone uses scripts.
Sure, but we'd also need to, it can't just be in the patch. It'd have to get copied into the patch description that gets fed into the changelog. Otherwise, once you start having to actually open the patch and look at the header, it gets very slow.
It would get very slow.
Yeah. But scripts log does that already. I mean, it takes the Bugzilla reference out of that tag and it copies it into the commit message.
So it could do the same.
Yes, correct.
So it enforced a kernel tools meta tag.
Yes, sure. No, it's great. So what Mel's saying is that we add an extra tag, like instead of patch mainline, we'd say patch userspace : true or something, and then scripts.log would pick up on that and enforce that
and then enforce it in the git hooks, not necessarily. Well, scripts log could warn about it, but enforce it in the hooks. So even if someone has the hooks disabled on their local repository, which is common, it would still get kicked back when they would try and push it to current CVS.
Sure.
I think would be the most reliable because they say and put it into a separate directory, people will forget. There'll be mistakes made.
Right.
Whereas we have lots of practice dealing with the metadata ones, and a new one that occasionally touches tools should not be.
Yeah, and I think this is pretty lightweight. I don't think most people they won't even notice it, and you know.
Most people, with the exception of yourself, will hit it if they get enthusiastic about Git fixes.
Right.
And then when it bounces back from current CVS, like it's one quick eyeball roll, throw in the tag, and push it again.
Okay.
It'll take them about 5 minutes.
Okay. Thomas, give us the naysayer view.
Yes. I mean, in theory, the stuff should be totally separated. This tools directory should build out of itself. In practice, there are some include files taken from the kernel, but these are bugs.
Well, that's not true. That's not true. There's a separate tools include directory that, through patches, gets mirrored from the include file in the kernel. So
yeah, but they're bugs. They should theoretically be cleaned up. I'm not sure how much they are for perf, but I had some. But anyway, so theoretically, the whole thing should be separated and built simply by make inside of the tools directory. Theoretically, you should be more or less be able, to copy away the tools directory and
but that sounds like an upstream problem.
Yeah, I mean, you are familiar with the kernel tools. But it makes things even more complicated. It's the same, I could imagine it's the same for the upstream people to get away from this, because you have the whole big kernel stack at your feet. I would more go the way for more separating the stuff. You have for some tiny tools, you need the whole huge kernel.
Sure, and I understand what you're saying, but I mean, this is kind of, we're stuck with we were using the upstream method. I mean,
I'm not sure whether is there a Git submodule on this tools thingy. Would that help to more separate this down?
No. I mean, the first thing is, I mean, if we do implement this, I'm not going to run around saying you can still have a user space package that BuildRequire's kernel source, and you can still put your patches into the local, if that's the way you want to do it. I mean, honestly, I mean, that's totally A-okay. I mean, it's especially if you've got a small number of fixes. The problem for perf is that the fixes are far more numerous, and as we get further away from the service pack, the backporting gets harder, which means we really need to do more aggressive backporting, which means that I don't want to use the local package anymore because it's too cumbersome. But if you have a simpler use case for yourself, keep on using it. That's fine.
Yeah, let's talk about this offline a bit more,
sure,
and let's find something in the middle. Maybe.
All right. Well, thank you, everybody. I appreciate it.
What's the time? So that I understand one thing, we're moving away from Robert's suggestion of storing the state in the package, right? The discussion veer away from that suggestion. Do I understand?
No, I'm going to talk to Robert and get a better idea of what he's doing and look at it. I mean, one thing that struck out to me right away, what if we have like 10 or 15 different user space packages all doing this? I mean, we could put them all into one kernel tools package like Fedora does.
Yeah, I mean, you just write a source service for every one of those packages. It checks out kernel source from Git, and then you run, I mean, I'm going to say you can probably even use the script that we have.
I thought you couldn't, I thought there was no network access to check stuff out of Git.
So you run it locally, you run the source service locally, that will generate your diff and your tarball if you want, and then that's what you check in. But the service itself is disabled inside of the
one thing that one thing that I think maybe that would solve is this issue of what happens when we publish these packages in the kernel source. You know, what if it hasn't changed? Do we end up issuing an update for all these packages? That might give us some control over that, because if we do tag the commits on the way in scripts.log, we still have the problem that we're going to basically release every one of these user space packages every time, and your solution might solve that.
Right. I mean, you control when you want to push it.
Yes,
right?
that's what it sounds like. So
in a local project, you would run the source service. Mm-hmm. You generate everything and make sure it looks like the way you want it. Then you run branch checkout from the SUSE namespace. That's what we do, and then we just copy it back in and submit that, and then we're done, right? I mean, yes, it's a two-step process for you because you have to go and commit it to kernel Git.
Yes.
And then
that's okay.
And
that's
then
okay.
manually go into
Right,
the package and run that.
So the issue I have is I don't want to commit stuff into kernel Git and then have to have a BuildRequire's kernel source because there's a disconnect there where you have no idea when this is actually going to emerge into the kernel source. But 4 minutes. But this sounds like it might solve it, and it doesn't preclude us tagging the commits.
No, it doesn't.
Anyway,
No,
so,
it doesn't.
Yes,
Yeah.
yes. Well, thanks for the suggestion. I appreciate it.
Michael Sukanek, you have 4 minutes. There is plenty of time if you want to.
Okay, there is additional automation for Git with OBS, which I'm not quite familiar with, but some people like have automation that they push stuff to GitHub, which is already done automatically with kernel-source. And then when there are changes on GitHub, the new package is uploaded to OBS, to a development project. And it's built, and it's tested that it built. And then you can submit the changes when you think that it's
Right.
good to submit.
Right. Which sounds somewhat similar to what Robert is saying.
Yeah, it's just automation for the surveys so that you don't have to check out the package and
Right.
run it by hand, but it's done by some automation.
Right, right.
A quick comment.
Yeah, no, just saying that what Michael just said is also what we are moving to and partly already moved to for a few packages, us in the virtualization team as well, namely QM on libvirt. The problem is that which we are also trying to solve, also related to the changelog, is that yes, this very convenient automation are also able to generate a changelog. What we, and I want to talk to Robert as well, because about how do they do that, because maybe it can solve our issue. The changelog is fine, but for example, it doesn't have the BSC references and stuff like that. Instead, we want that, and yeah, right now I have to go there and do it by hand, but yeah. But they're actually good, and it works fine.
Okay, well, I'll definitely touch base with you. But yeah, well, maybe we can touch base as we go along and see if we can kind of fix it for both of us.
Well, as far as I know, the service puts the messages from the from the Git log into the changelog. So if you put the bug references into your Git commits, then you get the bug references in your changelog.
Absolutely. What I don't want to do too much is especially if they are backports, I don't want to alter the subject of the patch or commit with Git. And also, it's also more work because I can just do a cherry pick and the patch is backported, and then I commit to the Git repository, and I'm fine. If I have to add the BSC reference there, so, well, yeah, maybe, I don't know. I have to add it in the commit message at least. So.
But you're interested in basically adding your commits into with the perf into kernel source.
Yeah, I mean you don't have to piggyback on the build service for everything, right? Because you can write a custom changelog generator, right? So you use the right? You use the build service for what it already knows, which is how to check out stuff from Git.
So when you say build service, does this apply to IBS as well as OBS?
Yeah, IBS and OBS.
Because IBS is the main interest that I have.
Right.
Yeah, okay.
Yeah.
But is this not always the same? Okay, we're done. We'll catch it offline. Thank you, everybody. Thank you.